Hello, YouTube freaks. I have a more serious video today. I think it's important because it's something that I was really bad at and still am. I think it's a little overlooked in economics just because we don't use them that often. But I think it's important to still know about them and how to use them. So I'm talking about the almighty integral. It's a consumer surplus with two bidders. A lot of the time when you're thinking about integrating in economics, you're thinking about consumer surplus, and this is that case. You got X first, you got Y second. We'll actually spell that correctly or write that down a little neater. So what we need to find is, and this is kind of like the tricky part here for this one, is you have your consumer surplus and 2, because symmetry. 1, x equals 0. It's a double integral, so it's multivariate, but it does simplify out a little bit, and it's not the end of the world. It's gonna look like a lot, but I don't want to scare you off just yet. Here's the thing. Learn the math of the integral. Like the antiderivative is important. It's kind of the whole thing. I mean, you've got your upper bound, lower bound, you've got your whatever shenanigans. Learn how to integrate, and then this will look less scary, but it might still look a little bit weird. So the first thing is there's an assumption that has to be made to get to this right here. There's an assumption that has to be made, and this was the question that was kind of being asked. And it's, we assume that f of x is equal to f of y, which is equal to 1 for all x and y in 0 to 1. So that's the assumption that we make. Essentially, what this means is because of this up here, of our assumption, this is just going to go to 1, therefore disappears. Which makes this a lot easier to solve, okay? Because this right here is no longer anything for you to worry about, okay? So your first step to solving this integral is you hold x fixed. So right now, oops, misspelled fixed. We're solving the inside integral first, okay? Which means we're solving, I'll show you this one. This is the inside integral. So how that works, we have our integral. I'll make a little bit smaller one because I'm running out of space on this page. I could always expand it, but whatever. V less t x plus y dy. And you can break down some of these inner terms so they become easier to work with. So like the v less t bracket, right? This is going to give v less t tx plus ty. And this is just a constant in y. So that's easier to work with. Love that. You can integrate term by term now. I guess I'll do a little bit of that. Again, I don't want to go over the actual, I guess maybe the question is if I'm not going over the actual math, then what's the whole point? But I don't know. I'm just doing this for fun. I don't know. I don't want to go over like the antiderivative because I feel like some people are just going to roll their eyes and other people are not going to know. That's not right. Other people aren't going to even know what to be confused about, right? Like I'm not going to have the right terminology or the right. It's just an antiderivative. So it's like a derivative, but it's the other way around. So, and everyone knows how to derive, so just do the opposite. Everyone knows how to derive, so just do the opposite, I say. Yeah, everyone's born with that knowledge. Come on now, get to it. No, guys, believe it or not, I'm still pretty bad at deriving sometimes, doing my derivatives. But anyway, you get to this point here, okay? You simplify a little bit up here, assuming this stuff right here, this stuff drops out. You're left with this over here because we've kind of we found a constant in y. I should probably write that down. Constant in y. Okay, so now we can do the next part. Again, 1 less x. I'm going to draw out all the bounds here. Essentially, what I'd expect you to do, I don't know if you're going to, I don't know if you're going to pick up on everything I'm doing right now, but essentially maybe pause this video, solve it yourself, and you will figure out, oh boy, kind of running out of room here. Pause it, look at what I'm doing, figure it out, watch a Khan Academy video, watch anyone else. Have like 3 monitors going. I'm kidding, guys. Just watch me. I'm clearly the best here. Okay, so you get this answer, and then you combine them both. So you have this. You put, if you can make this A and make that B, do A plus B or whatever. Guys, come on now. Easy peasy. A plus B gives. I think it was this. Yes. I don't want to do any trig integrals on this channel just yet because I'm not too comfy with those. We don't use those much in economics. You can, and there are instances where that does happen. So at some point we'll be doing like trig integral stuff. Like, I don't know how crazy I'm going to get with integration just because I find it quite difficult. And, I guess everyone kind of does. I think integrating is pretty hard. I think a lot of people could agree with that. But I still think it's important to do. So this right here, what you've just found is the inner result. So you found the inner result. Give yourself a pat on the back. Good job. And I will draw a little guy giving you a thumbs up, or what's supposed to be a thumbs up. That doesn't look very good. So anyway, this is your inner result. Now we have to do our outer result. I am going to expand the canvas just a little bit. Crop and resize settings. We want this to be longer, I think. Can it go up to 4,000? That would be great. Whoa, okay. So I guess we're just working up here now. So step 2, outer integral. So, and this one's from x equals 0 to x equals 1. Because this is the other one. So we're going to solve this one. 1, 0, integral, integrand. Beautiful, beautiful, beautiful. Beautiful, stunning. This is what you should be telling yourself while solving integrals. You should be like, I'm doing just beautiful stuff. I'm doing stuff that would make Oprah cry. Which, is Oprah still alive? I never really understood what made Oprah famous. Like, what did she actually do? I don't mean to be rude, by the way. Did she just do interviews? What did she do?
She had a game show.
She had a game show. I'm being told she had a game show. What was the game show?
So you get a car, you get a car, you get a car.
Oh, okay. I'm not very good at knowing stuff about Oprah. Don't ask me to do any Oprah-esque economics. The Oprah theorem. Okay? That everyone gets a car. If everyone gets a car, if every agent gets a car, then the economy collapses there. That's the model. Okay, so this is the outside integral. Thus, we can rewrite some things now, which you know we love doing. We love rephrasing. We love rephrasing in economics, saying the same thing like 84 times, just in a slightly different way, pretending we've actually done something. That's heat, by the way. I'm talking to you. I'm kidding. I love you. 1 less x. Okay, and we're gonna put it in polynomial form. Okay, everyone following along? Some high school math going on here, y'all. I know I've forgotten it. Boom, think that should be all right. That should be all correct. 2 is in front of 1 because I say so and I make the rules around here, last time I checked. So at this point, I'm just going to tell you, carry out the algebra and integrate. I'm just telling you to do that because quite frankly, I don't want to. This will give you, so you can check your result because I'm lazy, this will give you this. And if it doesn't, you've done something wrong. And I hate to be the bearer of bad news. You've done something wrong if you don't get this. This is not the answer we want. Why? Because you need to apply symmetry. So your CS is 2i, which gives you 2. And I'll carry out this algebra because this isn't a headache. Oh my gosh. I'm a true economist, guys. I'm maximizing. And this will give you your final answer. Now, there's a lot of assumptions that have to be made here, okay? I'm going to go and I'll be right back because I'm going to go grab the assumptions. The reason why I found this question on a forum, why it was on there in the first place, is because the person questioning it was confused about the assumptions that were being made. Because this result right here is only possible if both x and y are independent and uniform on 0 to 1, so that we can assume this. Okay? So if these assumptions don't hold, I'll kind of read this off. So we're assuming IID, we're assuming IID and uniform. That's our assumption, IID and uniform. And then you have cases where it could be IID, oh my God, why do I keep on doing that? IID but not uniform. So essentially the one-dimensional density f of u is CDF, capital FU, and is truncated first moment, m of u equals some sort of integral. We can kind of go over it. I was doing my nerd voice because I don't really understand, if I'm being honest with you. I've asked my handy-dandy AI what that would actually mean. And then for case B, even more, I guess, general would just be there would be an arbitrary joint law on 0, 1 to the power of 2. Can be correlated and asymmetric. So there's just a joint density on G x of y, okay? We can go over the two cases, but I don't feel like it. So we're not going to. And I want you as homework to go through this question and make sure you got it. As a little bit of a recap, number 1, use the assumption to simplify the integral. And then solve inner integral. Then solve outer integral. And then I guess finally for symmetry, which is pretty dang easy. You just multiply what you get by 2. All right? And then you're getting the same answer as they got. And I guess the paper, I'll just tell you what it is now so I don't have to put it in the description. You know what? I'll put it in the description because I'm just nice enough to do that. You're not going to read the paper. You know you won't. So it won't matter anyway. Thank you for watching, and I will catch you in the next video. If you don't subscribe, I'm going to show up to your house. That is a joke. Please do not be worried. You don't have to subscribe. I would appreciate it. I will not show up to your house.